I'm going to solve these simultaneous equations. So what I can see, I'm going to label them 1, 2, and 3. And then I'm going to need to use 2 of them to get rid of one of the unknowns, and then another 2 to get rid of the same unknown. So I'll go with 2 and 3 first of all, and I can add them together. This just seems like a good shout because the y's will immediately cancel. That's the one that I'm going to eliminate. So I'll be left with 5x plus 3z equals 19. And I'll just park that there for the moment. Right, now to get y rid of a different one, I think I'm going to deal with 1 and 2. And so I'll times equation 2 by 2. This will give me 4x minus 2y plus 8z is 34. I'll call this 2 dash. Now I've got the minus 2y and a plus 2y on the 1. I can add those two together. So equation 1 plus 2 dash will be, so remember it's this one and this one. So I'm going to get 5x again, then plus 11z is equal to 43. Oh, this is nicely set up, so I can actually now take this equation and I'm going to do the bottom minus the top, which will give me 8z equals 24. So z is going to equal 3. Now I've got that one, I'm well on my way to work out the rest of them, so I can put it back in. If I put it back into the top one, I'll get 5x plus 9 equals 19, so 5x is going to equal 10, therefore x is 2. And then I'll put it back into the very bottom equation. So then I'll get 6 plus y minus 3 is equal to 2. Well, that is 3 plus y equals 2, so y must equal minus 1. So x is equal to 2, y is equal to minus 1, z is equal to 3. What I think is a good idea is just to put it all back into even the first two, to be like extra careful to see if it all works. So I'd get 2 minus 2 plus 9. Okay, that works. And then 4 plus 1, that gives me 5, plus 12 gives me 17. It's got to be correct. B is then a vectors question. So I've got an origin, and I'm taking a vector to point A. This is not necessarily to scale, by the way. And then an origin to the point B. And I want to find the magnitude of AB. So let's first of all find out what AB is. Well, to get AB, I go from A to O, and then O to B. So it's actually going to be OB minus OA. Second minus the first position vectors. So I'm going to write it in vector form, 6, 2, minus 4, minus 1, which gives me 2, 3. Now I can find the magnitude. Because what we have here, I'm going to draw it to scale now roughly, is it's going to be 2 along and 3 up. Just try that last little bit again. 3 up like that. Okay, so that is my vector, and those are the components, 2 along, 3 up. Okay, so if I want to find the magnitude, I'm applying Pythagoras' theorem. 2 squared plus 3 squared square rooted, which is 4 plus 9, that's root 13. I'm also going to write it to 3 significant figures, so sometimes I see in the mark schemes, it does things like that. Because then I got it exact and 3.61. Now I'm asked for the angle that AB makes of the positive x-axis. So the positive x-axis is in line with this part here. So this is the vector I'm interested in. I'll call it theta. So sorry, that was part 1. Part 2, well, tan theta is 3 over 2. So theta is going to be inverse tan of 3 over 2. Which gives me 56.309. Or 56.3 degrees.